All right, so yesterday you should have kind of looked at a little bit exploring perpendicular and angle bisectors. All right, so today we're going to kind of explore that all out and do a couple examples for what happens when I have those things kind of happening. So first off, look at what is a perpendicular bisector, right? So the perpendicular bisector cuts a segment in half and meets that segment at a right angle, right? So if I kind of look here, I've got cutting it in half because I've got the two lines that are telling me that it's congruent, and it's meeting it at the right angle, right? So this right here is my perpendicular bisector. Okay, so some things happen when I have a perpendicular bisector, and I can pick any point on that bisector, right? So if you look at this right here, we're talking about I have this perpendicular bisector here of AB, and P is just some point on the line, right? So basically we're saying that PM is congruent or is perpendicular to AB, and that MA and MB are congruent, right? So I have the bisector. So when that happens, right, no matter where that point is at, if I were to kind of make a triangle, right, PA is going to be equal to PB, right? So if I have perpendicular bisector, can make a triangle that has two congruent sides, right? It works backwards too, right? So if you're given an isosceles triangle, right? So remember, a triangle with two congruent sides. And then if I were to make a point through point P, right? So through up here and drop it down, I get the perpendicular bisector. So you look at examples like this, right? A lot of it's just going to be setting up an equation. So you look here and say, what is happening, in this triangle? So I have is AC. I notice that I have two congruent sides and a right angle. So that means that BD, right, is my perpendicular bisector of AC. So then I know that BC and AB are congruent, right? So I can just set these equal to each other and say 4x is equal to 6x minus 10. And then I just have an equation that I need to solve, right? So subtract 2x. So I end up with, nope, I don't know where that 2 just came from. Right, let's subtract 6x. And so I have negative 2x equals negative 10. Divide by negative 2. So x is equal to 5. Right, and so now if I want to find the length of AB, which I know was 4x, you can take that and plug it in. So 4 times 5 can give me 20. All right, so the other thing I have is angle bisectors. So when we talk about angle bisectors, right, we're talking about something that bisects an angle. We've looked at these before. And so what kind of happens here is that if I have an angle bisector, all right, and so I have some point on that bisector, right? So here we're talking about S. If I were to make a line that's perpendicular to the two sides of the angles, right? So SR is perpendicular to QR, SP is perpendicular to QP. Then what I have happen is that those two segments are going to be congruent, right? So SR is going to be equal to SP, right? The length of those things are equal. And so then if I, right, and this one also works backwards, right? So if you have an angle, right? So here I have the angle PQR, PQR, all right? And I look and they tell me that there's this point S kind of inside the angle, right? It's inside the angle, and there's two segments that are meeting the angle at right angles and are congruent. So what I can say then is that if I were to connect, right, QS into that ray, right, it's going to bisect angle QPR. Okay, so that one works, kind of opposite of the first one. So look at kind of an example here. I look and I notice that I have this angle LMQ, or LNQ, sorry, and it's being bisected by NR, right? I can tell that because those two angles there are labeled as congruent. And I have these two segments, right? RM and RP, right? And they're meeting at a right angle. So because it's the bisector, I know that MR, right, is equal to PR. So I can set 7x equal to 2x plus 25 and work on solving for x, right? So subtract 2x, subtract 2x, 5x is equal to 25. So x is equal to 5, right? And then if I want to find the length of RM, right, I know that RM is 7x. So you plug in that x and say 7 times 5 is 35.